Hello, this is Ruby Insights, a channel dedicated to software engineering, architecture, best practices, and the tools that truly make a difference in professional development. If you are looking for technical clarity and a strategic vision of programming, subscribe to the channel and hit the bell to follow our upcoming content. Ruby Insights, engineering beyond syntax. Let's get into today's video.
Upgrading a major version of a programming language introduces significant structural changes to your environment. Attempting a jump to Ruby 4.0 without preparation exposes the application to immediate dependency collisions and removed API calls. To reach the 4.0.3 security patch and deploy it to production, we follow a three-phase roadmap: preparation, upgrade, and rollout. Step 1 begins with a strict boundary rule: freeze your Rails version. You will update the Ruby language first, stabilize the environment, and address the Rails framework separately. If a background job crashes during an upgrade, isolating the language change allows you to identify exactly which system layer caused the fault. This strategy ensures that any encountered breakages are clearly tied to the Ruby 4.0 runtime. Phase 1 starts on Ruby version 3.4. If your application is running on an older release, you must update to 3.4 first to use it as a diagnostic testing ground. From version 3.4, run your entire test suite passing the environment variable ruby-opt-w-deprecated. This command surfaces the warnings flagging methods and syntax that version 4.0 removes. Among these warnings, you will find errors regarding missing standard libraries. Version 4.0 extracts several default tools, such as the logger and IRB, and promotes them to independent bundled gems. You must explicitly declare these dependencies to prevent the application from crashing on boot. Add ostruct, logger, and IRB directly to your gem file. Next, update your specific API calls. Swap pipe-based kernel op commands with explicit io.popin calls. For Ractor communication, replace the removed yield and take methods with the new Ractor.port object. Iterate through the warning logs until the test output is clean. Achieving a zero-deprecation test suite on version 3.4 signals that you have addressed the primary architectural barriers documented for the version 4.0 transition. Phase 2 is the physical version bump. We are targeting Ruby 4.0.3 specifically to patch the memory safety vulnerability in the timeout handler, identified as CVE 2026-46727. Update the .ruby.version file to 4.0.3. Install the new version through your manager, and run bundle install to update the core structure. At this stage, your C extensions break. Gems like Nokiri are hard-linked to the Ruby 3 runtime, which no longer exists. To rebuild these links, run bundle pristine. This command discards old binaries and recompiles every native extension against the new Ruby 4 headers. Once the local environment passes, you must update your continuous integration pipeline. Modify Docker files and runner configurations to pull the Ruby 4.0.3 image. Changing the version number in your configuration file is not sufficient. CI systems often cache dependencies, meaning your runner may attempt to load old compiled gems into the new runtime. You must go into your CI dashboard and explicitly clear the vendor/bundle cache. This forces the runner to perform a fresh compilation. Local success does not confirm compatibility until the CI pipeline clears its historical state and verifies the build from scratch. Phase 3 moves the application to staging. Ensure your web server is updated to maintain compatibility and verify that the YJIT compiler flag is active in your startup command. Maintain the usage of YJIT for production workloads. While version 4 introduces ZJIT, it remains an experimental compiler. YJIT provides the validated performance stability required for live traffic. This is an APM dashboard monitoring the new 4.0 outputs. Backtraces now display receiver names like foo/bar and omit internal C-frames. Next to this, the memory utilization graph shows a shift caused by the new internal object layout for instance variables. These metrics establish your new operational normal. Proactively rebaselining your monitoring tools prevents the engineering team from investigating false anomalies during the initial rollout. Once error rates and memory usage hold steady in staging, you can authorize the final deployment to the production environment. The application now operates on a secure memory profile. The CVE is patched, the legacy deprecations are resolved, and the runtime performance is measurably faster. From this stable foundation, the team can begin testing the framework's experimental capabilities, such as Ruby.box isolation primitives, to build parallel testing or multi-tenant architecture models. Executing a disciplined upgrade path requires precise execution. By resolving deprecations and clearing caches layer by layer, the application moves from a state of accumulated technical debt to an optimized environment that supports the latest security standards and performance features.